All right, this is Ubaid on behalf of Electronics, and in this video we're going to be talking about our hypergeometric sequence. So this is hypergeometric sequence. Now, when it comes to your hypergeometric sequence is different, okay, or separate from your geometric sequence. Okay, this is separate from your geometric sequence. And the reason why it's separate from your geometric sequence is because, okay, your geometric sequence tells you, okay, the total number of failed experiments, for example, in your chemistry class before you land on success, before you land on the solution. Okay, so if you're mixing two chemicals, okay, it will tell you, X will tell you, okay, the exact number of the experiment when you actually get the solution that you need. So after four attempts, let's say four failed attempts, if you land on your solution, let's say you find the solution that you want, okay, let's say this is a chemical, let's say you use this for your car, okay, to seal any leaks. Okay, if you land on the successful solution, a sealant, okay, that stops any kind of leaks coming out of your car, let's say your transmission, okay, or any other part in your car, okay, then that number will represent X in a geometric sequence. In a hypergeometric sequence, on the other side, the hypergeometric sequence has to do with, okay, the total number of successful solutions within a given sample. Okay, so let's say you make an attempt, okay, to find that solution, okay, for your car, and let's say you tried that four times. Okay, and out of those four times that you try, that you make an attempt, okay, two of them are successful. So in two of the solutions out of four, okay, you have a sealant that actually seals a leak. Okay, so in that case, okay, this number two represents X. Okay, this number represents or is relevant to your hypergeometric sequence. Okay, now unfortunately, we don't have any TI-83s or TI-84s to figure this one out. So we may have to use the Excel calculator and the function on the Excel calculator to figure your hypergeometric sequence. And the formula for your hypergeometric sequence is something like this, where X is approximately H, stands for hypergeometric sequence, into R, this is the size of the first group, V, size of the second group, and N, this is the size of the sample. Okay, so let's take a different example. Okay, say for example, that you have a clinical study where, okay, let's say 11 people sign up, okay, for this study. These are 11 random people who sign up for this study. Now, out of those 11, okay, let's say six are healthy, and let's say five are obese. Now, obviously, this is your size of the population. Okay, these are total number of people who sign up for the clinical trial. Okay, and these two numbers, they add up to this number over here, 11. Okay, so 6 and 5 add up to 11. Okay, now in this case, if you want to figure out, okay, the total number of healthy individuals, just like if you wanted to figure out the total number of successful attempts, okay, when you try to mix two elements four times, if you wanted to figure out, okay, the probability of getting two healthy participants, okay, for this trial out of a sample of four people, okay, your four, this will be the size of the sample, and two, Okay, this will be the number of people that you need for this sample. Okay, so we're talking about healthy individuals over here. So healthy individuals. Okay, so if you were to write this, okay, in a formula, okay, let's say if you were to write a formula for this, okay, let's say this is x approximately h. This is the formula r, b, and n. Okay, r has to do with size of the first group. B has to do with the size of the second group. Okay, n has to do with the size of the sample. Okay, so in this case, let's say the size of the first group. Okay, this is 6. Size of the second group is 5. Okay, and they add up to 11 people in a sample or in a given population, not a sample. And the size of the sample over here, this is only 4 people. Okay, so for you to figure this one out, you may use your Excel function. Okay, on your Excel, okay, for your hypergeometric sequence, you will type in this function over here, this one, which basically says HYPGEOM period distance. Okay, so hypergeometric period, okay, DIST, into bracket. Okay, the first number over here, this is the total number of healthy individuals you need for your clinical trial. Okay, out of a given sample. Okay, so if you need 2 people, you will type in 2 for number of healthy individuals. Okay, and let's say your sample size, because you chose 4 people out of the 11, your sample size will be 4. Okay, 6 has to do with the size of the first group. Okay, so let's say the total number of healthy individuals in the given population, okay, of 11 people who signed up. Okay, this was 6, and the size of the population was 11. Okay, there were a total of 11 people who signed up for this clinical trial. Okay, and over here, okay, if this is a non-replacement, okay, where okay, the people you choose for your study do not get replaced. Let's say the people who okay are picked. Okay, and let's say you've got 2 people out of a total of 4. Okay, these guys they don't go back in the sample. Okay, once you choose them. Okay, so these are non-replacement samples. Okay, samples that are not replaced. Okay, which means okay, the selected few do not go back in the sample. Okay, if this is a lottery, let's say you win a number. Okay, let's say you win a raffle. Okay, that number does not go back in that raffle box. Okay, once you take that number out, once you win using that number, okay, that number is permanently removed. Okay, so in this case, 2, 4, 6, 11 false. Okay, and this will give you the percentage or probability when it comes to individuals who are healthy for your clinical trial. Okay, so in this case, this is 0.4545, which rounds up to 45%. So 45.45%, this will be your probability for your hypergeometric sequence. Okay, that will be it for this video.